Hello and welcome back. In this video, we'll start chapter 28, Value at Risk. There is a mini exercise associated with this video, so you can apply what you're learning. Let's get into it. Value at Risk is an important risk management tool, and it answers a question that I feel like a risk-averse investor would be pretty interested in, something like along the lines of, what's the most that my portfolio could lose in value in a given time period? And answering that question can provide some reassurance, but it can also be misleading. So let's get into it. It is there's a couple components of value at risk. So in this example, 5% annual VAR of $10 million. So there's a time interval, right? Annual, how much can my portfolio lose in a given year? You could also do like a monthly VAR or weekly or daily or even hourly VAR, value at risk. What's the most my portfolio could lose in a given hour? Right? So the time interval is specified. There's a probability level, 5% in this case. And then it's expressed either in terms of dollars, the value, change in the value of a portfolio, or in percent terms, like portfolio returns. So there's two interpretations of value at risk. I want you to be ready to provide both, understand both. I like this minimum loss interpretation better than the next one, and I'll explain why. But this minimum loss interpretation says that, okay, with a 5% annual VAR of $10 million, value at risk of $10 million, that means that 5% of the time the portfolio will decline in value by at least $10 million per year, right? So 5% of the time, one out of every 20 years, right? 5% of the time, the portfolio will decline in value by at least $10 million. So like the loss will be at least $10 million in those 1 out of 20 on average bad years. So this tells me, gives me a sense of, okay, in the worst years, the worst 5% of years, 1 out of 20 years, will lose at least $10 million, right? Maybe much more. The maximum loss interpretation I find potentially misleading, but it's the kind of thing that an investor would probably want to know or get any risk averse investor would want to get a sense of, like, what's the most I could lose, right? So let's talk through the interpretation. So here it says that there's a 95% chance, right? 1 minus the stated probability. 95% of the time, the portfolio loss will be less than $10 million in a given year, right? So it looks at those 19 out of 20 years on average that aren't the worst years, right? So normally, most of the time, 19 out of 20 years, the portfolio loss will be less than $10 million, right? Hopefully the portfolio goes up in value most years, but 95% of the time, the loss will be less than $10 million. But what this ignores is like the worst years, right? And that's where I want to measure risk, the years where the returns and the changes in values are the worst. So I want you to be comfortable with these interpretations. There's 3 ways that we'll talk about to estimate value at risk. Benninga in our textbook only looks at 1, but these other 2 are important, and I want you to understand those as well. But let's look at the mean variance method. And if portfolio returns are normally distributed, right, that's a big assumption in this mean variance methodology. If we assume a normal distribution, we have a really good sense of the shape of the distribution. And let me see if I can draw a normal distribution here. Give it a try. It's a good start. Some kind of bell curve. Suppose this probability density function corresponds to how the returns on my investment portfolio are distributed, right? And so we know that with the normal distribution, most of the observations occur near the mean because the PDF is higher near the mean. And then we also have a good sense of the amount of area in the tails of the distribution, right? And you remember from stats class or the simulation chapter that, with the z-score of negative 1.64 about, right, 95% of observations are going to be to the right of that z-score. And remember, a z-score is equal to x minus mu over sigma, right? So with the normal distribution, Right? The 5th percentile of the normal distribution is z equals negative 1.64. So what that means is 5% of the time with the normal distribution, observations will be 1.64 standard deviations below the mean or more. Right? So value at risk in terms of a normal distribution is closely related to these z-scores. And actually, when we find value at risk, you're essentially solving this z-score formula for x. And if we look back at the formula, we can see the value at risk is equal to the mean plus the standard deviation times some z-score. I'd encourage you to take some time to try to map out like the z-score formula to the value at risk formula. And if you can understand the connection, I think you'll be in good shape. But let's do an example. If we've got a portfolio's average return and its standard deviation, what is the 5% annual VAR in percent terms? So I think I've got a Word document open. Yes, with this. So the 5% annual VAR value at risk for this portfolio looks something like this. Right? The portfolio's average return is 6% per year, and then the standard deviation is 11% per year. Multiply that times negative 1.645, which corresponds to the 5th percentile of a normal distribution. All right, so if portfolio returns are normally distributed with a mean of 6%, standard deviation of 11%, we know that 95% of the time our observations will be less than 1.645 standard deviations below the mean. 5% of the time there'll be 5% of observations will be at least 1.645 standard deviations below the mean. So if you go through and do all this math right, you should come out with a figure of about 12.1%, I believe. Yeah, I got negative 12.095% or negative 12.1%. Okay, so that means that the minimum loss interpretation, right, 5% of the time, the portfolio's return will be at least negative 12.1% or worse. Yeah, the minimum loss interpretation. Maximum loss interpretation, 95% of the time the portfolio's return will be better than negative 12.1%. Right? 95% of the time we'll lose less than 12.1%. That's the maximum loss interpretation. So again, use that with caution. But this assumes a normal distribution. And if you want to, suppose we've got the portfolio has a market value of $20 million, what's the 5% annual VAR in dollars? I'll see if you can figure out that on your own. And I think the formula should help you do it without too much trouble. Okay. Well, I hope you enjoyed this video on computing a discussion of value at risk and estimating value at risk using the mean variance method. Your mini exercise is to find some Wall Street Journal article that discusses value at risk and briefly summarize it. So in the next video, we'll talk about some more methodologies to estimate value at risk, and we'll get into it with actual portfolio return data. Thanks as always for tuning in.